Hello everyone and welcome back. My name is Mr. Kowald, and in this video we're going to talk about heterogeneous equilibria. That is where you have reactions that involve not only gases or concentrations but also solids and liquids. So let's get into this. So when you're writing the expression for equilibrium constant, as we said, you want to include the concentrations or partial pressures of your substances into the equation expression. Okay, so if we were to do that, we would put in, if we're taking here's our first equation. If we were to follow what we said before in a previous video, we would write the expression as K. So your K value would be equal to, and then it would be the concentrations of your products over the concentrations of your reactants raised to their power. So we would write CO, concentration of CO raised to its power, which is 1, multiplied by the concentration of carbon, which is also 1. And then we would have CO on the bottom, so the concentration of CO, this should be CO2. So we have CO on the bottom, and we have a coefficient 2, so that's going to be raised to the power of 2. And this is what you would write as your equilibrium expression. However, this would actually be wrong. So this would not be right. And the reason for that is because we have a solid here. And so we can't really think of the solid is going to, as far as concentration goes, solids don't really change their concentration, right? So, and the reason for that, and this goes for liquids as well, is that liquids and solids, we're talking about pure liquids and pure solids, they don't really expand to take up the volume of their container, right? So because they have a constant volume, or a constant density, if you will, then the concentration is not going to change. So as far as a solid is concerned, their concentration is solely dependent upon their density, right? And so the density of a solid isn't going to change unless the temperature changes, but we're assuming that the temperature doesn't change. And so therefore, the density is not going to change, and therefore its concentration isn't going to change. So since this is a constant and it's based on the ratio of these changing, since the concentration or density of the solid doesn't change, we don't include that in the expression. So the actual expression would be K is equal to, and then we just include the gases. So it'd be the concentration of your CO2 over the concentration of your CO raised to the 2 power. So this would be the correct equilibrium constant expression for this first reaction. And so the same thing would go for this reaction here. So you might think, based on what we said before, is that the K value would be equal to these two, right? So you have the concentration of H plus raised to its power, which is 1, and then multiplied by the concentration of this ion here, your hydrogen carbonate ion. So CO3 minus raised to its power, which is the coefficient 1. And then you would have put that over your concentration of CO2. So you got CO2 gas, coefficient 1, so power of 1, multiplied by, and then you have water here, which is H2O raised to the power of 1. So you would think that this would be the equilibrium, the expression of the equilibrium constant. But again, because water doesn't expand to fill its container, it doesn't change volume. So basically, the uh, concentration of water is going to be dependent upon just its density. And since we're holding temperature to be constant, then the density shouldn't really change. And so this will be a constant. So we're not going to include that in our expression for the equilibrium constant. So we would have to get rid, so this would not be right. So we'd have to get rid of water. So the correct expression would be everything without the water. So we have the H plus on the top multiplied by the concentration of HCO3 minus all over the concentration of CO2. And so that would be the correct expression. So the upshot of this video is to show you that whenever you have a solid or a liquid, pure liquid, in your equation, you are not going to include those in the expression of your equilibrium constant. So you leave those out. So anything that's a gas or anything that's aqueous, only those things will be included in your expression. I hope this was helpful. I hope you learned something from this video. If you enjoyed this video, please hit that like button, subscribe to my channel, hit that notification bell so you'll be notified by other videos I put out. Just a moment. Sorry, the light went out again. So don't forget to put a comment in the comment section, hit that notification bell. Let me know what you think and if you have any questions. Thanks for joining me. Have a great day.